Okay, so hello everyone, how are you all? Welcome back to SISYA Class channel, and as promised, once again I am back with the new. Hello everyone, how are you all? Welcome back to SISYA Class channel. Once again I am back with the new chapters of grade 8, that is a story of numbers. Okay, so basically this is gonna be the last chapter for grade 8 one short series, right? We have covered all the chapters, either you can see part 1 book or part 2 book of Ganita Mazari. Every chapters we have done. Okay, one promise I'm also doing with you, that we will also come back with the NCERT example. Okay, all the questions of NCERT we're gonna solve from the next day. So if you want to watch that, stay with the SISYA Class channel. Clear? So what we're gonna cover today, it's all about the story of numbers. So what is there in this chapter, do you know? So now everyone know that how to count, right? 1, 2, 3, 4. But have you ever wondered, when the numbers were not there, how they used to count? How they used to count their animals, how they used to count like number of trades of goods, how they used to do that. There was a problem, right? So today we're going to study about the history of numbers. Basically this class will look something like a history class, but if you want to know it, if you want to know the chapters, stay with me till the end, you will understand everything. Okay, so before starting the class, all of you know what you have to do. Just let me give you a brief intro about myself. I am Dhananjay, a maths master teacher at SISYA Class, and I have 2+ years of experience as a teacher. Mainly I teach for the JEE and foundation. Okay, so basically what you have to do, just visit the sisyaclass.com/LTC. There we have many courses going on right now, like booster course, maths champ course, or SISYA toppers program. What you have to do, visit this site sisyaclass.com/LTC, tap on your grades, any grades, and then you will have this pop-up. Fill in the mobile number and your state name and you are good to go. Now let's see what are the chapters we're going to cover today. First we will see, why did humans start counting? Okay, first let me give you the motivation behind this chapter. So first of all, tell me that what happens if numbers were not there? What will happen? Can you, if let us suppose now we have 1, 2, 3, but earlier it was not like that, no? So what if 1, 2, 3, if you don't have these numbers, so how will you first of all count? You cannot imagine the world without numbers, right? How will you like count the money? Most important thing, how will you count the scores of any sports? This is not possible. Like you cannot imagine the world without numbers. So this is the motivation. Let's study that how all the numbers originated. So first of all, see, why did humans start counting? The second thing is birth of Hindu numerals, the digit 0. Then we will see what exactly a number system means. Then early system, what we used to do, how we used to count, like through sticks, through letters, and through tally bones. Okay, we will look at counting in groups. So one by one counting we not used to do. We also used to count in groups as well. That we're gonna study. Roman numerals, all of you know. This is one of the most famous number system, that is Roman numerals. Next is the idea of base, that is the Egyptian system. And at the end we will look at the place value and the most important number system, that is Hindu number system. Okay, so all of you understood what we're gonna cover today? Fine. Okay, so let's start with a story. Actually, everything starts from this story only. Actually, see, she has some curiosity. She's a girl and she has some curiosity. She has got a piece of paper and there are some symbols made there, right? Her name was Rimas and she went to her father and asked some basic questions from her father, like, since when have humans been counting, father? Like, Papa, when we have started counting the numbers? That was the first question. Second question was, what are they counting and why they are counting. This was her second question. Third and fourth question was, how would Mesopotamians write a 20, 50 and 100? What are the symbols for that, for 20, 50 and 100? And at the end, she asked about when do we write numbers in the modern way? Since when we started writing any numbers in modern way? This was her last question. So basically at the end of the class, we will be able to answer all the 4 questions. So stay with me till the end. So why did humans start counting? So necessity is the mother of invention, right? So suppose if you have to count the number of animals, basically what they used to do, they used to herd the animals, right? So how will you count that how many animals do you have, how many animals do their neighbor have? So there is a necessity for counting, right? Necessity for counting. So in this situation, it's needed. Quantity of food stored, that what is the quantity that we have stored the food. There also we needed counting. Keeping track of exchanges between groups. So these are some situations that we needed, and we should have numbers for counting, right? Then time, calendar, like predicting the new moon, full moon, onset of seasons. Okay, but back then there was not like Hindu numerals like we use today, right? So where all of these things started, we're gonna look at it in this chapter. So let's start with how we say numbers begin in India. Okay, firstly let's start with India. Like for 1, what we used to say? Eka. Okay, for 1 we used to say Eka, 10 is Dasha, 100 is Shata, 1000 is Sahasra, and 10,000 is Ayuta. It's just a name given, like 1, 10, 100, 1000, 10,000. Now we know, no? But earlier it all started with Eka, Dasha, Shata, Sahasra and Ayuta. Everything, if you will see, that is 10 to the power, right? 10 to the power 0, 10 to the power 1, 10 to the power 2, 10 to the power 3, like that, right? So 10 to the power 0 means 1, right? When they have taken the base as 10, they call it as Eka. Base 10 power 1 is Dasha, base 10 power 2 is Shata, base 10 power 3 is Sahasra, base 10 power 4 is Ayuta. Clear? So this is how the numbers begin in India. But they have taken the base 10 only, right? So there was some problems, right? Now let's see where the birth of digits 0 to 9 came from. Okay. So don't worry, it might sound like a history chapters, but it is like that. Okay. So I'll try to make it very interesting. Don't worry. So first, so today what we write, the numbers 0 to 9 was developed in India only, from 0 to 9. First known use all 10 digits including 0. 0 was notated simply as a dot. Okay. So earlier what they used to do, no? For 0, they used to denote it as dot only. That's it. For 0, the notation was dot. Okay. Now I'll link everything with the current number system. Okay. It was not like that before. Now I am connecting with current number system that still it is going on. That is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Everyone knows. Okay. So for 0, they used to call it as dot. Okay. So first of all, 0 it was appeared. First of all, 0 was appeared. Okay. So this was all about the birth of digit. Now let's come to how the digits 0 to 9 evolved. Okay. There was a different notations back then, like in Brahmi, they denote 1, 2, 3, 4, 5, 6, 7, 8, 9, like this. Okay. This is just a notation of numbers. In Hindu, they used to denote like this. In Sanskrit or Devanagari, whatever you say, we denote the numbers like this, and at the end we have a number system from 1 to 10 like this. East Arabic, there was different notation. West Arabic, there was different notation, right? 11th century, means what is going on here? Many handwriting across 2000 years, the shape drifted, but the place value idea never changed. Okay, only the difference is here. The meaning is same, like 1, 2, 3, 4, 5, 6, 7, 8, 9. Meaning is same, but the notation is different here in each one. If you'll see, Brahmi, Hindu, Sanskrit or Devanagari, West Arabic, East Arabic, 11th century, 15th century and 16th century. This is what going on currently. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? Hindu number system. Right? 1, 2, 3, 4, 5, 6, 7, 8. This is the easiest one. Right? That is why it is accepted now. Clear? So this is the notation of 0 to 9 with time. Okay. Now let's see a Stone Age problem with the cows. Okay. Basically what is going on here? So they have some cows. Okay. And there in their mind he has some questions and he has to answer. See how numbers are evolving with time. That is what we are doing. Okay. So the question was, there were some 3 questions. 1, 2, 3. Okay, what are the 3 questions? First question was, did all the cows return safely after grazing or not? This was the first question. Second question was, do we have fewer cows than our neighbor? The third question was, if fewer, then how many more cows do we need? Okay, let's repeat first question. First question, did all the cows return after grazing or not? सारे गाय घास चरने के बाद वापस लौटे या नहीं लौटे? This is what we have to answer in the first question. Okay, right? Second question was, do we have fewer cows than our neighbor or not? Like अपने पड़ोस से कम cows है या ज़्यादा cows है? How will they compare? Right? Obviously, they will need some base to compare it. And the third question was, in fewer, how many more cows do we need? Okay, let's answer one by one. First of all, without using the number, the challenge was without using the numbers or numerals now we have, that is the Hindu number system, you have to answer this question. Now it is easy to say like 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8. Sir, we have 8 cows. But back then it was quite difficult to find out how many cows we have and all the cows return safely after grazing or not. Okay, so what they used to do, for every cows they used to map with one stick, and basically it is 1-to-1 mapping only. Clear? Like for this cow they have given one stick, for this cow, one stick for each cows. Clear? But you have to keep a rule in your mind that the associating of each cow to a different stick means no 2 cows can get the same stick. It should be different. So at the end what they used to do, this is called a 1-1 mapping first of all, because for every cows we are giving the one stick, right? Yes or no? For every cow what we are doing, we are giving a one stick to each cow, and at the end what they do, they just see the number of sticks there. They used to see the number of sticks, and that is how they find that the cows return safely after grazing or not. Okay, this was the answer for his first question. Clear? Like for 1 cow, how they used to denote? They denote with 1 stick. For 2 cows with 2 sticks, 3 cows 3 sticks, 4 cows 4 sticks, 5 cows with 5 sticks. Okay, but the mapping should be 1-to-1. Clear? Okay, but there were some problems in this as well. So what they did, for every number they associated with some letters. Like for 1, what they did, they associated with A. For 2, okay, let me tell you. For 1, they associated with A. For 2, associated with B. 3 with C. 4 D. 5 E. Like that, you can associate 26 only, no? 26 only with Z, right? But what after 26? The counting will stop. After 26, the counting will stop or not. So there was some limitation. So using only English letters, we cannot represent any collection of more than 26 objects. Clear? More than 26 objects, if it will be there, how will you represent it? What will be the name given to it? So they used to say like for 27, it is AA. For 28, it's AB. But it was becoming quite difficult, right? Quite difficult. What about 100? What about 1000? What about 10,000? How will you denote it? It will sound very difficult, right? So this was also not perfect for counting. Yes or no? So this is clear to you. Now let's move on to the next thing, and that is the symbols. Now we have symbols for each number. See how? I think everyone is familiar with these symbols, that is the Roman numerals. So for 1, they denoted with I, this is the letter I. For 2, what they did? 2, 3, 1, 2, 3, 4, 4, 1 V, 4, 5, 4, 5, it is V, 4, 6, 7, 8, 9, 10. In the same way, for 10, it is X. Everyone knows it now. So these are some notations given, or you can say symbols given to the numbers. Like for object, if we have one object, I'll denote it by I. If we have two objects, you will denote it with 2 sticks, you can say, or 2I, you can say. For 3, we have 3 sticks. For 4, 1 V symbol. For 5, V symbol. For 6, V1 symbol. This is the alphabet, right? V and I. For 10, we have X symbol. Clear? In the same way, till 20 you can denote it. For 20, what it is? X and X. Clear? So these are the symbol notation first of all for every numbers. But again, if I'll tell you what happens later on, okay, we'll study in Roman numerals that for 50 there was new symbols. For 100 there was no new symbols. For 500 there is new symbols. For 1000 there is new symbols. What about 10,000, 50,000, 60,000, 100,000? How will you denote it? Again and again there will be different symbols. So there is some limitation or not? Obviously there will be some limitation. Okay, we will see it in Roman numerals. Fine. So first of all, let's start with what exactly a number system is. So basically a number system is can be a sequence of objects, it can be a sequence of names, can be a sequence of written symbols as well. Okay, that is used for counting. That is called the number system. And numerals means it's just a symbol that is given for counting. Like the written symbols to a number system, example 0, 1, 2, all these are called numerals, right? This is the Hindu number system, no? That is why you can relate it very easily, okay? Now next is the landmark numbers. This is some definition that you should know first of all. Landmark numbers is like there is some base that is taken to count all the numbers, like 5, 10 is taken some base. Like किसी भी नंबर्स को काउंट करने के लिए सबसे पहले जो बेस चुना गया, लाइक मोस्ट ऑफ द बेसेस आर लाइक 10, 20, 60, all these are bases, right? So these are called the landmark number. Clear? So landmark number was necessary back then. Why? Because how will you denote the big numbers? If you want to denote it, firstly you will need these base numbers, yes or no? You will need, suppose if you are taking base as 20, then only you can denote 400, right? I am relating with now, see how will you denote the 400? So 400 you can write it as 20 square only, no? 20 square is 400. That is the Hindu number system. So 20 is a base here, right? So it is needed to denote any big numbers. So basically landmark numbers are these base numbers only. That's it. Simple. Clear? Okay. Okay. There was one country, that is Papua New Guinea. They use their body parts to count the numbers. See how? See how? In their fingers, they have counted like 1, 2, 3, 4 and 5. They have used their elbows as well. They have used their wrist as well. They have used their shoulder as well, ear, nose, and they counted till 27 only. This is where the number system started. Okay, they counted till 27. But what after 27? How will you count it? It will become difficult, right? So then the next system will come. Obviously, we will talk about that. But what if there is a numbers like 50, 60? How will you use your body parts? For 70, for like 75, right? How will you use their body parts here? It will be difficult for you. Okay. Okay, now let's see the number names that is built from counting in twos. Counting in twos means, suppose for 1 it is given as Urapon. For 1 the name is given as Urapon. For 2 how you can write 2? 2 it is Ukasar. 1 it is Urapon. 2 it is Ukasar. Then you have to count in twos only. Okay, base you have taken as 2. Now you have to count with 2, with the help of 2. For number 3, how will you denote number 3? 2 plus 1. So for 2 it is Ukasar. For 1 it is Urapan. 2 Ukasar, 1 Urapan. So Ukasar, Urapan. 4 how will you write? 4 equals to 2 plus 2. So 2 plus 2 means Ukasar, Ukasar. 5, 2 plus 2 plus 1. So Ukasar, Ukasar and Urapan. That's it. This is what you have to do. Means they have taken base as 2 here. 2 plus 2 plus 2, 4, 6. Ukasar, Ukasar and Ukasar. Right? So this is the number name that is built with twos only. So this is clear to you? Fine? Okay. Now let's move on to the next thing. And earlier what we used to do, we used to count the numbers like 1, 2, 3, 4, 5. But people faced difficulty when they have group of objects. Like here we have 4 objects, 1, 2, 3, 4. But they directly unable to think that how many objects they will have. Okay. Here we have how many apples? 5 apples. But directly thinking 5 apples is easy now. Back then it was difficult. Okay. This group of grapes also. So C is Rima's, right? This is increasing her curiosity that how will they count the groups. Okay. How will they count the groups? Like common group sizes were like 2, 5, 10 and 20. Right? Now it is 2, 5, 10 and 20. But what they called back then for 2, 5, 10 and 20. Okay. So this is the interesting question that she has in her mind. Right? So then come the Roman number system. For grouping, they have given some symbols. Clear? Grouping, they have given some symbols like 1 to 10. Everyone knows how to denote it. 1 to 10, and I have cleared it. 1 to 10. Now let's come from 1 to 10 is fine. Then 10 to 40 is also clear. 10 to 49, it was clear. Like suppose if you have to write the 35, how will you write it? 310 and then 5. For 5, how will you denote it? V, right? So till 49 it was clear. Now what after 49? They have different kind of symbols, right? For 50 they have given as L, for 100 C, for 500 it is D, for 1000 it is M. Means at every, if you will see, after every numbers, after some interval, there is some new notation of numbers, right? But it is difficult to count the bigger numbers, right? Like 10,000, 50,000, 1 lakhs, 10 lakhs. How will you denote it? There will be many notations, right? Okay, so what you have to do, suppose if you want to write the 27, okay, let's see some examples of Roman number system. So 27 is quite easy, right? How will you write it? For 27, you can write this as 10 plus 10 plus 5 plus 1, right? Break it down first of all. 10 plus 10 plus 5 plus 1 plus 1. So 10 plus 10, you can write this as x. For this 10, you can write x. For 5, you can write it as v. And 1 can be written as I and I, right? So 27 in Roman numbers can be written as XX V1. This everyone knows now. Clear? Clear? But the important thing here is, no, suppose if you want to write down 4. So there was rule like 4, 5 we have V. 4, 3 we have C. 4, 1, 2 we have 1. 4, 2, 1, 2. 4, 3, 1, 2, 3. 4, 4, how will you write it? You cannot give 4i here. 4i is wrong. This is completely wrong. No. So what they did, we can write 5, 4 as, first of all, 4 can be written as 5 minus 1, yes or no? So what is the notation for 5? See here, what is the notation for 5? For 5 we have B. So 4 minus 1, you have to write down before this V. 4 plus 1, you have to write down after the V. Since here it is minus 1, so we have to write IV. This is the notation for 4 and this is the rule that they made. Clear? Okay. So suppose let's take one more example, and that is how will you write 440? 440 you cannot write this as x, x, x and x. This is completely wrong. This is wrong. Because why it is wrong? Because only you can give 3x, not 4x. So this number is near to 50, right? This number is obviously near to 50. So 440, you can write this as 50 minus 10. Once again, this is a subtraction. So first of all, write down the notation for 50. 50, what we use? 50, it is L, and for 10, it is X. XL is the notation for 50. So this is all about the Roman number system. Clear? Roman number system, I think most of you are familiar with this. Clear? Now let's see how addition works in Roman number system. Multiplication. See, addition works, but multiplication hurts. Very interesting topic. You can add the numbers, that is fine. But what about the multiplication? What about the division? It will become complicated. Okay. Like for example, we have here, see this example we have like CC X X X double I, right? And then C 4C, then X, then triple A. How will you add these two numbers? So first of all, count how many C we have. 1, 2, 3, 4, 5, 6. Means 6 C we have. So shall I write here? So it should be 600. 6C means what? C denote for, first of all, see the notation for C. C we have 100. So 6C means 600. So first of all, how will you denote the 600? Now 100 we have C. For 500, new notation. For 500 we have D. So 600, how will you denote it? So first of all, you have to write here D. This is the 500. 6C means 600, right? Then if I'll give it C, so 600 you can write as 500 plus 100. So I told you, no, when you have plus, you have to write down right side of this letter. So this is DC. Now let's count X. How many X we have? 1, 2, 3, 4 means 40. So how will you write 40? 40 means 50 minus 10. So for 50 we have L, right? And 50 minus 10 means XL. Clear? Means 50 minus 10. Before X means I am subtracting 10 from L. L means 50. So DCXL. Now this is 1, 2, 3, 4, 5. 5 means we have new notation, that is phi. So this is how you will add the numbers in Roman numbers. Clear? But Roman numbers addition is, you can do it. That is still fine. It will take some time, but multiplication is quite difficult here. Multiplication also, division also. There is a big limitation in this, in multiplication and in division, right? How will you multiply it? Can you multiply these two numbers? Can you multiply it? No, it becomes difficult, right? So obviously there will be new number system will come, that we will discuss it. Next we will see the Egyptian number system. Egyptian number system, they have taken the base as 10, like, and they denoted with some specific symbol for each base. Okay, like 10 they have taken as base. So what are the numbers we will have? 10 power 0, 10 power 1, 10 power 2, 10 power 3, 10 power 4 till 10 power 7. They have given some notations. Please remember it. For 1 means basically 10 power 0, right? 10 power 0 is 1 only. For 10 power 1, 10 power 2, this notation, 10 power 3, this is the notation, 10 power 4, 10 power 5, 4, 6, 4, 7. It might look complicated now, but they used to solve the questions like that. Okay. See, suppose if you want to write 324. First of all, how will you write it? 324 in Egyptian number system. 324 means this is 3 into 100, means basically 3 into 100, right? 3 into 100. Then we have, this is 300, right? Then 20 you have to write. So 2 into 10 you can write. 2 into 10 plus 1. That is 4 into 1. See, what are the bases we have? 1, 10. 10 base I'll have now. So I'll try to convert numbers into power of 10 only. See, this is 3 into 100. So can I write 100 as 10 square? 100 को मैं 10 square लिख सकता हूँ, बिल्कुल. 10 को मैं 10 power 1 लिख सकता हूँ. 1 को मैं 10 power 0 लिख सकता हूँ. Obviously 10 power 0 we have this notation. Now I'll have notation 3 10 square means I have to give this notation 3 times. So I'll write this as 3 times. Simple. Now this is 2 into 10 power 1. 2 into 10 power 1. So what is the notation for 10 power 1? This is the notation. So, and how many times we have to write it? 2 times. So I'll write this as 2. Now next I'll have 10 power 0, but it is 4 times. 10 power 0 is I. So I'll write this 4 times I. And this is how you will denote 324. Sounds complicated now, little bit, but this is how it was. Okay. So sometimes what happens now, they were given these symbols and they used to try to convert into these numbers. Okay. But that time it was not like Hindu number system. That is why everything was so complicated. Okay. So this was all about the Egyptian number system. They have taken the power. So first of all, they have taken the base as 10. Then we will see the different bases. First they started with the base 10, and for every powers of 10 they have given one notation. Clear? So this was all about it. Next we will see the base n number system. But bases can be different as well. Okay. So how will you create the base n number system? Like first landmark will be obviously 1. Okay. Let me tell you one more thing. Here 10 was the landmark number, right? I've told you, no, the base that you have taken is a landmark number only. First landmark will obviously be 1 because you will take power as 0. So it will be 1. every next number will be previous into fixed number. Okay, suppose here next base I have taken as 5. First it was 4. First it was 4, 10. Now I'll take it as 5. So 5 power 0, suppose I have denoted with a triangle. 5 power 1 is a square. 5 power 2 is a, with this symbol, like it is like hexagon. 5 power 3 with circle. 5 power 4 with this notation. 5 power 5 with this notation. Suppose if you want to write the 143 in a base 5, that was for base 10. Now it is for base 5. How will you write it? 143. So 143 base 5 means 5 to the power something. First of all, you have to create it. So 5 power something. So how will you split this 143? 5 power 3 is 125. We know. So can I write 143 as 125? Okay, sir, 125. Now again I have to write it as 125 plus 5 is 30. Then 135. 140 plus 3. How will you write 3? 1 plus 1 plus 1. Right? Now see, the beautiful thing here is 125 can be written as 5 to the power 3. Then this is 5, obviously 5 plus 5, that is fine. I will leave it is 1 plus 1 plus 1. Now 5 power 3, there is some notation or not? Obviously we have one circle, right? 5 power 3 is 125, and for that we have notation one circle. Next is 3 5 we have. 3 5 means 5 power 1 here, no? 5 power 1, so 3 square I will make. Three square I will have. Next is 3 1. So 4 1 I will have triangle. So I give 3 triangle. This is how you will denote this 143 in symbols as a base 5. Previous was for base 10. For base 10. How will you denote the numbers using symbols? Next, this is for base 5. This is the landmark number. 5 is a landmark number here. In the previous concept, 10 was the landmark number, right? Now let's see what was the shortcomings for the Egyptian system. So obviously there will be shortcomings because after 10 to the power 7, they have given till 10 to the power 7 only. See here, symbols till 10 to the power 7 only. What about after 10 to the power 7? Like obviously there can be a numbers greater than 10 to the power 7, like 10 to the power 20, 10 to the power 50, 10 to the power 100. What about this? How will you denote it? So obviously there will be many symbols, so it become complicated, no? So what was the necessity next? We have to find a way to represent unending sequence of numbers. How will you represent any numbers which is unending sequence of numbers using finitely many symbols? Obviously you cannot use the infinite symbols, no? And this is exactly what place value will solve. Next we are going to learn about the place value. This is where the problems are solved. Okay, one by one we will see it. The first is the Mesopotamian number system. Mesopotamian number system, and this is called as Babylonian number system, obviously. So Mesopotamian number system is still, it is seen in your clock, right? They have taken the base as 60. For 60 it is called as sexagesimal, that is fine. They have taken the base 60 and 1 hour obviously, 1 hour equals to 60 minutes, everyone knows now. 1 minute equals to 60 seconds. But important thing here is they have taken the base as 60, that is fine. But 60 to the power 0, again we will do the same thing. There will be some notation for that. There will be some symbols, 60 to the power 0, 60 to the power 1, 60 to the power 2. They have some symbols for that. So 60 to the power 0 we will denote this, 60 to the power 1 we will denote like this, 60 to the power 2. ओके, यहां पर देखो एक प्रॉब्लम ये सोल्व हो गई कि they have used the same symbols but they are writing the powers in the middle of the symbol, right? 60 to the power 2, 60 to the power 3, so 60 to the power 9 will be like this only, no? They will write 9 in between. Okay, so this is quite little bit easy than before, but still it will have some limitation. This is how you will denote a number, bigger numbers like 3600, 60, 20, 2,16,000. This is how you will denote, no? 2,16,000, no? Yes, 2,16,000. This is how you will denote 60 to the power 3. 60 to the power 3, yes, this is correct. So this is how you will denote it. First of all, you will try to convert every numbers into powers of 60. Into powers of 60. But for 1 to 59, there is a symbol. After 60, you will denote, no? This. What about the numbers before 60? So for 1, they have denoted like this: 2, 3, 4, 5, 6, 7, 8, 9, 10. Only they have taken two symbols like this. This is the first symbol and this is the second symbol. With the help of these two symbols, they have created all the numbers. Like for 1, so they have taken this one. For 2 means 2. For third, you have to make 3 figures. For fourth, you have to make like this. For 5, you have to make like this. And for 10, there is a new symbol, that is something like a less than symbol. Okay? With the help of these two symbols, they have created numbers from 1 to 59 in this way. And this is how they will denote any numbers. Like for 60, though, they knows that 60 will be denoted like this, right? Okay, we'll see. Let's see some examples. How will you write in Mesopotamian number system for 640? Give the symbols for 640. So 640, I have told you, no, make base as 60 first of all. So 640, how will you write it? 640 can be written as 10 into, okay, 600 first of all, write it down. 600 and then 40 can be written as 40 only. Obviously 40 I have symbols, 600 I don't have symbols. So 600 I have to convert it into power of 60. So can I write this 600 as 10 into 60? Obviously I can write, and then this is 40. So 40 I'll have symbols, 60, how will you write 60? 40 I'll have symbols and 60 I have symbols. Okay, fine. Then how will you denote the 60? 60 can be denoted as 60. So obviously I'll have 60, I have this notation 60, and then for 40, what is the notation? For 40, this is the notation. For 40, this is the notation. Okay, how they denoted 40? 1, 2, 3, 4. Like this they have denoted, no? 1, 2, 3 and 4. This is how you will denote 10 into 60 plus 40, right? 10 into 60 plus 40. But okay, let's denote one more number, that is 7530. 7530, first of all, how will you write it? See, try to convert all the numbers into 60 to the power. So 7530, if you will try to write it, you can write this as 2 into, okay, first of all, you have to write here this symbol 10 times, okay? 10 times you have to write it. So 2 into 3600, can you write this? Because 3600 we can break into 6 to the power, that is fine. 2 into 3600 plus, how will you write it? 5 into 60 and then 30. Please add this one, you will get 7530. I am trying to convert into the power of 60. Power of 60. Power of 60. Okay. Can you tell me what is 36 100. So can you write this as 2 into 60 square, means 60 to the power 2. Obviously I can write this 2 into 60 to the power 2. Next is 5 into 60, 5 into 60 and then 30. 5 into 60, then 30. What is 10 into 60? First of all, okay, in previous question 10 into 60, 10 for different notation we have. Yes, 10 for 10, I will have this notation. So directly you can write down less than sign, then 60 and then this symbol represents 640. In previous question. In this question, how will you do it? For 2, I will have notation. What is the notation for 2? This is the notation. For 2, 60 squares. For 60 square, I will make this symbol and in between I will write 2. Right? This is 60 square. What about 60? What was the notation for 60? 60, I have this notation. In between I will make 1. But I have to make 5 also. So 5, how will you draw it? This is how will you draw it 5? See, notation you have to remember. 5, this is the symbol we can use. So this is the symbol for 5. Next is 5 into 60. So 60, this is the notation, and 30. 30 I will have notation. This is for 10. So for 30, like this. This will be the notation for . This will be the notation for 7530. Clear? 7530. This is how you will denote it using the Mesopotamian number system. Clear? Okay, let's move on to the next number system, and that is called the Mayan number system. In Mayan number system, what are the landmark numbers? In previous number system, Mesopotamia, what was the landmark number here? 60, right? Now the next will be the 20. It is somewhere 20. See how. First of all, the landmark numbers is like 1, 20, 360, 70, 200. How this is coming? First of all, they have taken the base almost as 20. See how. 1, 20, how you can write it? 20, so that is fine. They have taken base. What about 70, 200? For 70, 200, they have taken as, I think, 20 into 18. Clear? This is how 20 into 18 you will get 70, 200. First of all, let's do it. No, 360. 360. So 20 into, okay, the third number is 360, right? So 20 into 18 will be 360 only. How will you write 70, 200? Then 14, 1,44,000. Yes, 1,44,000. How will you write it? With the help of 20 only you have to create it, because base I have taken as 20 only. Clear? In Mayan number system, the base is 20. In previous number system, the base was 60, right? Clear? Okay, we will do some problems based on this later on, then you will understand it easily. Okay? See, if you can see this figure, it is easy for you. How will you write this? How will you read this? First of all, 364, 20, 11, 1, 0. Okay, so first of all, 4 into 360, 11 into 20, and then 0 into 1. What is the overall number? 4 into 360, 11 into 20. So this is the notation for 1660. Okay, whatever is written there, you can write it down like this. 1660 can be written as 360, then here 4. So 4 into 360, then 20, here 11, 1, then 0. Clear? Basically, it is trying to say 1660 can be written as 4 into 360. Why I have taken here as 360? What was the base here? 360 only, no? Right? 360. So I am trying to convert it, and I will give the symbol for that. Then 11 into 20. Why I have taken 20? Because the base was 20 as well. Then 0 into 1, obviously there is no need because these two numbers adds up to 1660 only. So 0 into 1. But for notation I have to give this. Clear? So 4 0 they have used this notation. For this one they have used notation, and for 4 they have used 4 dots. Clear? For 360, sorry, for 360 they have used this one. Clear? So this was all about the Mayan number system. Now let's move on to the Chinese number system. Okay. In Chinese number system, what they have taken base as? Okay, first of all, let me see in Chinese number system. Okay, in Chinese number system, how they used to denote the numbers, like 1 for 1. See this figure. This is clear by the figure only. For 1, they'll have jongs and hengs. One for the vertical, another one they have used a symbol as horizontal symbols. For 1, in jongs they have used this symbol, like it is somewhere like tally marks, what you can say. No, it's like a Roman number also, it's combination. For 2 they have used 2 sticks, 3, 4, 5, 6, 7, 8, 9. Okay. For hangs, how will you denote it? 1, 2, 3, 4, 5, 6, 7, 8, 9. This is how you will denote the numbers. Okay, let's do one example. Like suppose if you want to write down 2634. 2634 in the Chinese road number system. Chinese number system basically. How will you write it? Basically you have to convert it into the powers of 10 first of all. Powers of 10. So how will you write it? 2634 can be written as 2 into 10 to the power 3, right? Just try to write it in the power of 10. No? 2634 can be written as 2 into 10 to the power 3, then 6 into 10 square plus 3 into 10 plus 4 into 1. We have to split down these numbers into powers of 10. Clear? I think this everyone knows how to do it. In the powers of 10, how will you write these numbers? Like this only. Now what after that? How will you denote using a symbol? How will you denote using a symbol? So this is, okay, see here. 4 2, 4 2, 4 2, how will you denote? 2 hangs, no? 2 hangs means 2 horizontal line you will give. 6 jong means the T, its symbol like T here. See what you have to do, 4 ones, okay, let me see, 4 ones you have to denote with hang, and 4 tens you have to denote with, sorry, 4 ones you have to denote with jong, 4 tens you have to denote with hangs. So it will go like jong hangs, jong hangs, jong hangs, like that. Clear? Jong hangs, jong hangs, jong hangs. So how will you denote? If this is jong, if this is, oh sorry, if this is hang, this will be jong, this will be hang, this will be jong. Right? So 4 2, how will you denote it? See 4 2, what is the notation in hangs? Hangs notation is this. So I have denoted like this. 6 will be for jong. 6, how will you denote it? T. Okay. 3 4 hang. 3 4 hang, what is the notation? This is the notation for hang. 3. 4 4, once again jong. So 4, what is the notation for 4 in jong? This is how will you denote. So this pattern you have to follow. Hangs, jongs, hangs, jong. Clear? I hope this is clear to you. So this was all about, it's looking like a Chinese because it's a Chinese number system only. So this was all about the Chinese number system. Now let's come back to the final number system, and that is Hindu number system. and I think I don't need to explain this because everyone is master of this Hindu number system. Why? It ended all confusion because there is no different notation other than 0 to 9. See, only we have 9 notations in Hindu number system. 0, 1, if there is no object, I'll denote with 0. 1 object, I'll denote using this symbol. 2 object, this symbol. 3, 4, 5 till 10. Okay, 9 it is fine. What about 10? 10 I'll denote with 1, 0. Then the first digit I'll change only till 20. 1, 2, 1, 3. This is how we'll proceed. And I don't think that I need to explain this Hindu number system. So let me read this one. So every position powers of 10 is shown just by where the digits sit. Obviously, no separate landmark symbol needed at all. Yes. Like example, if you want to write 375, so everyone you can write now, because we are relating only with Hindu number system, everything. So this is 10 to the power 2, means basically it's telling that this is 300. So it can be written as 300 plus 70 plus 5. So 3 into 10 to the power 2 plus 70. Can you write 70 as 7 into 10 plus 5 into 1? Obviously you can write it down. And you know how to write it. Clear? So this was all about the number system. I hope everyone understood this chapter. I try to keep it very simple. It might sound little bit history type, but this is what it is. Okay? And this is how every confusion came to an end. Now go back to Rima's question and answer everyone. Every question you can answer now. Okay? This is some homework questions that I have given to you. Please try it once. You have to represent 948 in Roman numerals. Obviously, you can do it. You have to convert 512 into Egyptian numbers. Represent this number is Mesopotamian number system. And you have to create a landmark for base 6 system. Try it. I'll come back with the NCERT solution. Then I'll solve all the problems. Clear? So if you want more sessions like this, what you have to do, everyone knows, visit the sisyaclass.com/LTC. There we have some courses going on right now, Booster course, Maths Champ course and SISYA Toppers program. Please visit it. Whatever the grades you are in, tap on your grades, enter the mobile number, that's it. Our mentors team will contact you and then you can enjoy the courses. Fine. If you like this session, please subscribe the channel, share with your friends. And next I'll meet you with the new videos with NCERT solution. Till then, have a good day. Bye bye.